Okay, so the first part, I've got to write 4 cos theta minus 2 sine theta in the form of r cos of theta plus alpha. I like expanding that first right hand side first, so it'll be r, and that'll be cos theta cos alpha, and then I've got plus in the middle, I get minus here, and it's sine theta sine alpha, but I've got to times by the r as well, so it's r sine theta sine alpha. And this was giving me my two equations, because first off I've got the 4 lots of cos theta, and here I've got r cos alpha lots of cos theta, so the first equation will be 4 equals r cos alpha, and I'll call that equation 1. And the second equation comes from here. I've got minus r sine theta sine alpha. I know only sine theta, so I've got minus 2 sine theta, and here I've got minus r sine alpha. So that tells me that 2, I've got the minus sign and the minus sign there, so I don't need any of that. So 2 equals r sine alpha, and that's equation 2. And I'll go back to using blue. Two things. If I square this, I'll get r squared cos squared plus r squared sine squared, and that will help me. That will work out what we've got. So first off, I'm going to do equation 1 squared plus equation 2 squared, and that will give me 16 plus 4. Exact square in the left hand side, and square in the right hand side will give me r squared cos squared alpha plus r squared sine squared alpha. Factorize this to get r squared times by cos squared plus sine squared, which is 1. So this says that 20 equals r squared, and therefore r equals the square root of 20, or that's square root of 4 times 5, which equals 2 root 5. And to get the other bits, I've worked out what r is. To get the other bits, I need to divide them, and so I'm going to do equation 2 divided by equation 1, and that will give me, I'll do it on the right hand side first, r sine alpha over r cos alpha equals 2 over 4. So equals 2 over 4. R's cancel out, so that gives me tan alpha equals half, and so alpha equals 26.565 degrees. So I've got that first bit, and now I can do the second bit. So part 2, I'm not sure I'm going to have enough room around here, but we'll see how it goes. Part 2, I've got to solve this equation. Well, that says that I've now expressed this bit, and it's exactly the same as that, so it becomes here. So it becomes root 20 times cos of theta plus 26.565, and that's got to equal 3. So divide by root 20, so it says that cos of theta plus 26.565 equals 3 over root 20. I now need to get rid of cos, so inverse cos. So with theta plus 26.565 equals cos to minus 1 of 3 over root 20. And then I've got to work out what this is. So I get theta plus 26.565 equals, that gives me 47.86958. Or when I do the inverse of cos, I'll always get that, or I get negative that, so negative 47.86958. And each of those repeats every 360 n degrees, so plus 360 n. I now need to take away 26.565, so theta equals 47 point whatever, take away 26 is 21.3045 plus 360 n degrees, or minus 47, take away 26 is minus 74.434, and that's plus 360 n. But it says the value has got to be between 0 and 360, so theta equals, first one is definitely 21.3 degrees. If that's n is 0, if n's 0 here, then I get minus 74, so actually I'm going to have n being 1, So it's minus 74.434 plus 360. If I do that, theta equals that, or 285.6 degrees. So that does that next bit. And part C, I'll do this bit in red. Determine the greatest and least values of this, and in each case find the smallest positive value of theta for which that occurs. Okay, so let's do the greatest first. So this is part B. We've got to do the greatest. Well, if we think about this, then I'm going to have to take away something. So I want this bit to be as small as it possibly can be. So, oh no, it's squared. So if this bit has got to be 0. So the greatest value will occur when this is 0. So greatest when, and we know what that bit is, we just worked it out in the first bit, it is this expression down here, put the ring around it. That's the other way of writing that. So the greatest form when root 20 times by cos of theta plus 26.565 equals 0. And if it equals 0, the greatest value is 25. So I must write down what the greatest value is. Greatest value is 25. When does it occur? It occurs when it's 0, and therefore this bit must be 0. So cos of 90 is 0, therefore theta plus 26.565 must equal 90, and that tells me therefore that theta equals 64.435, and that's when it's 25. That's the greatest, and now we need the least value. So the least value, well, it occurs when this expression, the root 20, that bit, is as big as it possibly can be. And the biggest this cos value here could be 1, or indeed it could be minus 1. So minimum value occurs when cos of theta plus 26.565 equals 1 or minus 1. Okay, and so therefore we get this bit has got to be, ends up being 0, because cos 0 is 1. So this tells me that theta plus 26.565 equals 0. So theta equals minus 26.565. Can't be that one, because it's got to be a positive value of x. So hopefully it's going to be this one. How does it get to be minus 1? Well, that will tell me that theta plus 26.515 has got to equal 180, because when the angle is 180, cos of 180 is minus 1. And so there we get theta equals 180 minus 26.565. So that's theta is 153.435 degrees. And so we need to find out what the minimum value, min value, is 25 minus the square root of 20 squared. I suppose it's minus the square root 20. That would be minus 20, so it'll be 25 minus 20, which equals 5. And that's the least value. And I hope you follow that. That's question 8 done.